Good morning, everyone, and welcome to KETIV's Autodesk Virtual Academy, your once-a-week learning resource for any and all Autodesk products. We're here every Thursday morning at 10 a.m. Pacific time to give you the latest and greatest in Autodesk technology and news. So, I'm Nigel Mbike, application engineer here at KETIV Technologies, and today I'm joined by special guest Alex Alvarez. Alex is one of our Fusion 360 engineers and specialists here on the team. I'm sure I'll talk about a few more of his roles here shortly as he introduces himself, as this is his first webcast. Woo!
This is the first one.
Congratulations on that one. So today we're going to be going over an introduction into 3D printing with Fusion 360. So if you don't already know what Fusion 360 is, it's a kind of a one-stop shop for your entire manufacturing process. So you can take your product from concept to like physical reality, whether that be a physical prototype, or sending it to your CNC machine, all without leaving a single tool, which is huge, I think. Just giant innovation in regards to design products moving forward. And Alex is going to go over a couple of the intricacies in regards to getting your part ready for 3D printing, because there's some specifics in regards to watertight bodies and things like that, and he'll go over those in his presentation. But without further ado, I'll go ahead and let Alex take over.
Thank you for that, Nigel.
Yeah, go ahead, Alex.
So a little bit about myself. I am a student at Cal State Fullerton. I'm a fifth-year mechanical engineering major there with an emphasis in manufacturing. I will be graduating in May, so I'm pretty excited about that. I can definitely see the light at the end of the tunnel. So I'm an intern here at KETIV. My role is to provide support for anything Fusion 360 related. So any questions, comments, or issues you may be having with the program, they do get directed to myself and Brian. If you ever need to reach out to me, my email is alex.alvarez@ketiv.com. So like I said, if you just need to reach out to me for advice on using or how to go about something, feel free to do so. Okay, so a little bit of an overview of what we will be doing today. Let's say you're out with your boss and he starts talking business to you, right? We've all been there once or twice. And let's say he pulls out a sketch pad and he starts sketching a model, and he gives it to you and he tells you, okay, I want you to model this.
And I want a prototype this afternoon.
And a prototype. So we're going to talk about how to import that sketch onto Fusion 360. Now, obviously, if it's not a parametric, sketch, then you are going to jump into surface modeling. So we're going to talk about that. We also want to make sure if we're going to get it 3D printed, we want to make sure that we have a watertight body. So what I mean by that is you want to make sure that your surface model has no gaps in it, or else you're not going to be able to get that solid body that we're looking for. Finally, we're going to talk a little bit about Mesh Mixer. Now, Mesh Mixer is a preprocessor that comes with Fusion 360. You do have to download it. It gives you the option to download it like once you're ready to send it to Mesh Mixer. You could use whichever preprocessor you like, really. It's up to you, but for today, we're going to use Mesh Mixer. We're going to talk a little bit about its user interface and just how to get your part ready for 3D printing. Okay, so what is 3D printing? 3D printing is another form of additive manufacturing. So completely different from what we're used to, the subtractive manufacturing, where you have a piece of stock and then you have a machine removing material, creating your part. So additive manufacturing works in the way of so think of your the cross section of your part. The 3D printer looks at that cross section and it starts building up layer by layer. Now those layers can range from 0.1 millimeters, which is on average 3 to 4 thousandths of an inch, which is pretty thin. Now they can get a little bit thinner depending on the quality of your 3D printer. You do have some pros with 3D printing. The biggest one being that it is cost effective. So instead of spending on tooling or coolant for your machines, all you really have to spend on is the filament for your 3D printer. You can also build complex designs. There really is no limitation when it comes to 3D printing. The only limitation really is your build space, right? So if you're going to build a pretty big part, you want to make sure that you have enough build space for that part.
Right, and if it is too big for your build space, there are ways to glue 3D printed parts together. So what you can do is you can actually split your part into multiple sections.
Definitely.
I've seen that happen. People have made like cool plastic helmets and stuff, or like masks.
Yeah.
That don't fit in their build space. Yeah, so they'll do like a gluing technique to get those fused together.
Yep, definitely. You can also make prototypes with it. So instead of having to spend money and time on creating a part, made out of metal, and then finding out at the end that it didn't fit or it didn't work the way that you wanted it to, you can create a 3D printed prototype and then spend a couple minutes, if not maybe less than an hour, depending on how big it is, and then going to your assembly and making sure that it works the way that you want it to, or that it's doing what you ask of it. So it's extremely effective when you are creating some prototypes for it. Now you also have some quick turnover times. I was reading an article a couple weeks ago about a fuel injection part for an aerospace company, and on average it took around 6 to 7 months to create that part and assemble it all together. Once they 3D printed it, once they went over to 3D printing, it took under a week to create that same part. So there was a pretty big gap in turnover times, and I'm pretty sure that in the future we will see this technology evolve a little bit more. There is a downside to 3D printing though. You don't get that same strength of material as you would, obviously from a metal part. So the majority of 3D printers are printing plastic parts. So obviously you don't get the same mechanical properties as you would from steel or aluminum. Now you do have metal 3D printers. They are a little bit more expensive sometimes, but it's worth it. That technology still hasn't evolved that great, so they're still working on it, making it a little bit better. So here we have the different 3D printing techniques. So the most common one that we're used to is SLA, which is stereolithography. So the way that works is the machine lays down a thin polymer resin, and then you have a UV light that goes over it, and it solidifies it, creating that thin layer that I was talking about earlier. You also have SLS, which is selective laser sintering, and DMLS, which is direct metal laser sintering, which is the one that creates the metal parts. So here, if you look on the screen, this is a sketch that we're going to be creating the surface model about. It was a quick sketch that I came up with, so nothing too complicated. So yeah, let's go ahead and jump right into it. All right, so first thing we're going to want to do is bring in that sketch. So let's go over here to Insert, Attach Canvas, and let's go ahead and start on the front plane. For our image, let's go ahead and select our image. Let's go to Desktop, AVA, open. All right, so we bring the front plane normal to us. Okay, so we see that the picture isn't in the correct orientation. So now to flip it, let's just go ahead and click on horizontal flip. And we want to make sure that the opacity is 70. Now you don't have to keep it at 70, but I find that that gives us the best results when you're creating your surface, and you can still see the edges that you created. You also want to make sure that display through is checked. You want to see through your canvas, so that's why we want to make sure that it's checked. So let's go ahead and click OK. Now what we want to do is scale up the sketch. So with scaling up, pretty much, I mean, it's what it is. You scale it up to what it would be in the real world. So let's go ahead and scale the part up. Right-click on your canvas, calibrate, and we know that these 2 points are 120.65 millimeters. We see that it gets scaled up. Let me just bring it. What is that front plane? Okay. So we see that it gets scaled up. Okay. So now let's say you have a different view of the canvas or the sketch. You can definitely insert multiple canvases onto your workspace. So let's go ahead and insert a right view of it. Let's go to Insert, Attach Canvas. On the face, we're now going to select the right plane. So it seems to be lagging a little bit. Let me just try that one more time. Attach canvas. Face is going to be the right. Okay, there it goes. Image, it's going to be this right view. Okay, so we see here that it inserts the canvas. Now we want to do the same thing and calibrate it. So let's go ahead and right-click on your canvas, calibrate. Right-click on the top and the bottom, and we know that it's 120.65. Click on OK. And we see that it gets scaled up. Now we want to position both of these canvases with respect to our origin, right? We want a place to start. So let's go ahead and turn on our origin since we don't see it. Let's go over here to the left and turn the light bulb on, and we see that our origin appears. Let's go ahead and work on this right view real quick. So right click, edit canvas. Okay. Now we want to move this. Oh, sorry about that. I'll move the point instead of it. So right click, edit canvas. You want to make sure you're dragging the arrow, not the point. Make sure that you're right to it. Okay. Now I'm going to position it the bottom center of the origin over here. So the bottom center of the part is going to be my origin. Now you can really position it wherever you like, but I find that the bottom center works best. Now you see here, it's not a perfect sketch. I do have, it's not a straight line, but it doesn't matter. You can just position it close to where you think it's going to be at. So let's go ahead and click OK. Now let's do the same with the other one. So right click on your first one, edit canvas, drag the arrow up, make the front plane normal to you. Okay, bottom center. So that looks about right. Let's go ahead and click OK. So now if you just do a quick rotate, you see that you have both of your canvases scaled appropriately. So now we can go ahead and insert our surface onto this. So to do that, let's go ahead and click on Create Form. And we see that we're now in the sculpting workspace. So let's go to Create Cylinder. Now we're going to start from the bottom plane. Start a cylinder from the origin. And we see that the cylinder appears. Now I selected a cylinder because by looking at the handle, you see that that's pretty much the basic shape of the handle. So let's go ahead and just get it to the right diameter. So 38.1 millimeters. If we take a look here, we also see this handle up here. So this just controls the number of faces that your surface is going to have. So obviously, the more complicated of a surface that you have, the more faces you're going to want. That's just to give you more control over the surface. If you have a lot more curvature here, then you're obviously going to want more control over that. So let's go ahead. 6 works for me, so 38.1. Just go ahead and drag this up. Okay. Now, symmetry is already selected for me, but usually it's not selected, by default. So pretty much what this says is that whatever you do on this side is going to get done on this other side, right? So we don't want to do something on this side and then have to mimic the same thing by hand on the other side. So that's why we create symmetry. It's just time efficient, and you're going to get the correct results. So we have symmetry about this line. Everything looks good. Let's go ahead and click OK. And now we can go ahead and start sculpting our surface. So let's go ahead and right-click, edit form. If you double-click on an edge, you should select it. It's going to select all the adjacent edges that are around that edge. So let's go ahead and just rotate this about that. Now, funny story, when I first started surface modeling, it did get a little frustrating. Reason being is that you really have no structure when it comes to surface modeling, right? So you just kind of go based on how it feels or like how it looks correctly. Whereas, if you're doing a parametric sketch, you have, dimensions and values that come along associated with that sketch. But with surface modeling, you really have no direction of where you're going, no sense of direction.
Right. And I look at it this way: like as engineers, we work in like definite numbers. So something like a 128.65 or that 38.1 there at the bottom. Those are things that just like subconsciously I'm thinking. Whereas opposed to things like this that Alex is creating, like, sure, like it looks good, but maybe it's like 137.796, and that's like something I'll never, type into a parametric modeler as a size for something. It's just kind of based on feel a little bit here for surface modeling, but you do get some more organic shapes as opposed to something like, just creating normal geometric shapes.
Yeah, so I'm not going to bore you with the detail of getting this model exactly correct. So here I already have a finished surface. So once you're done with that, it should look something like this.
How did you do that so fast, Alex?
So if you look over here to on the right view, you'll see that I did take into account the right view that we had, the right canvas that we inserted. So everything is the way that the canvas looked like. So now what we want to do is make sure that we include the details that come along with our handle. So to do that, let's go ahead and begin. We want to make sure that we start with half of the surface. So now you don't really have to start with half of it. It just makes life a lot easier working on one half and then mirroring that half over. So let's go jump into the patch workspace. Click on modify, split body. We want to split this surface and our splitting tool. We see that our origin is this one right here. Our planes appear. So we want to split it about the front plane, right? Because that's the half. That's going to be half of our surface. So let's go ahead and click OK. We see a little preview up here. Let's click OK. So now we click on the bodies. We see that two bodies have now appeared. We can go ahead and hide the second half. And here now we see that we're going to be working with just that left half. So let me go ahead and just drag it up. So now what we want to do is remove this little strip in order to create a sweep there. And also, if we look closely, we see that there's an offset in this surface, so we want to go ahead and split that as well and just offset that surface. So let's go ahead and right-click, repeat split body. We're going to repeat split this body with respect to the spline. Click OK. So right-click, repeat split body. And we see that our sketch is hidden, so let's go ahead and turn it back on. Going to be our splitting tool is going to be the spline. Click OK. All right. So now, most of you are familiar with working in the model workspace. So when you're working in the model workspace, you have to have a closed profile when you extrude something, right? But here in the patch workspace, you can extrude open profiles. So here, take for example this spline. We can just extrude it an arbitrary length. Go ahead and click OK. And now this is going to allow us to remove that strip. So let's go to modify, trim. Our boundary is going to be this. Our excess material is going to be that little strip. And you see that it turns red, indicating that that's the area that's going to get stripped or trimmed. Click OK. Now let's go ahead and hide that body that we just created. OK. Let me just hide the canvas for now and our sketches. OK, so now let's go ahead and offset this surface. To do that, let's go to and create, hit on create, and click on offset. Click on this face, surface, and then let's say 2 millimeters. Click OK. So we rotate it, we see that that surface got offsetted by 2 millimeters. Let's go ahead and hide that first surface. So this is what you should end up with.
And just note here, everybody, that we're still in like a surface workspace. None of these are actually solids.
Yeah.
And so there is like a couple of more things to do in regards to getting ready for 3D printing. Just letting you guys know that you can't just have a like a surface model and send it to your printer.
It has to be a solid body in order to create that STL file that we're looking for. Okay, so now to create the profile for the sweep, let's go ahead and sketch an arc on the, oh, that wasn't the right plane. Stop sketch. Let's try that one more time. Hit on sketch. First, you know what? Let's go ahead and start with the intersect. So most of you, if you're familiar with SolidWorks, this is similar to the pierce command in SolidWorks. So what this allows us to do is actually start the sketch from a point. So let's go ahead and select the points that we're going to be sketching on. Okay, all right. So now what this allows us to do is when we jump into a 3-point arc, now we rotate it here. We see that we can select the points that we just created. So let's go ahead and just create an arbitrary arc around there. We can go ahead and click Al for line. Just make an arbitrary line. Click OK. And now we're ready to create those sweeps. So to do that, let's go ahead and click Create Sweep. And we see once again that our sketch is hidden. So let's go ahead and turn on our sketch. All right, single path profile is going to be this line that we just created. The path is going to be this top path. Click OK. And we see that the sweep was created there. Let's go ahead and do that one more time. Right click, repeat sweep. We see once again that the sketch is hidden, so let's go ahead and turn it back on. This time we want to create a path and guide rail. The reason why we do that is because we want this profile to stay within these boundaries, right? So by hitting on path and guide rail, our sweep is going to stay within these two boundaries. So our profile is going to be this arc, path, and guide rail. Since it's a perfect offset, it doesn't really matter which one you pick for the path and the guide rail. So I'm just going to select the top as a path and the bottom as a guide rail. And we see there that the sweep gets created. Okay.
Very cool. So just a note there in that last dialog box, there is an option for chain selection. I'm sure a lot of you do know what that means. But for those of you who don't, what that chain selection box will do is it'll follow whatever path you use, like all the way around its profile.
Correct.
So if you, go ahead and just click that real quick, Alex, and show people. If you do select path, if you select the path, it'll select the entire path all the way around the perimeter of that surface.
Mm-hmm.
So that's something, if you're like, oh my gosh, what's going on?
Make sure you just
maybe uncheck that. Yeah.
Yep, there you go. Okay, so our ultimate goal really is to create a solid body out of this, right? So when I was first doing surface modeling, I was like, okay, our part is going to be filled with material, so we don't really care about this excess material that's sticking out right here. The problem becomes though when you're going to stitch your surface. Fusion 360 picks up this excess material as open edges, so it's telling you like, okay, hold on, you have a big gap there. We can't proceed with creating that solid body. So if you ever get an error when you're on the last step, when you're going to create the stitch, make sure you have all your edges trimmed up nice, and that should be a reason why you're getting that error. So let's go ahead and trim that up. Go to Modify, Trim. Let's go ahead and select this as a boundary, this as the excess material. Click OK. Right click, repeat trim. So this as a boundary, this as the excess material. Click OK. And we see here now that we have everything trimmed up. Okay. Now what we want to do is mirror this surface. So let's go to Create, Mirror. We see in the dialog box, so faces is okay for this. Objects, instead of selecting each individual face, we can just click and drag, and it selects all the faces that we have here. Let's go ahead and mirror plane. Our mirror plane is going to be this front plane. Click OK, and we see that the mirror appears. Now what we want to do is cap off the top and the bottom. So let's go ahead and hit on Create. You could just click on the top. By default, the patch command is going to be on the top. So again, you want to make sure that you don't have enable chaining. Sometimes it works. So if you had enable chaining, sometimes it would select this circular edge, but sometimes it selects some crazy edges. So just to be safe, let's go ahead and deselect enable chaining. Let's go ahead and select that top one. Click OK. Once more, right click, repeat patch. Click OK. So we see here that we have everything closed. So now we have a watertight seal. We should be able to stitch this up and create a solid body. So let's go ahead and stitch it up. To do that, on top of Modify, the default command is also Stitch. So let's go ahead and once more click and drag instead of selecting all your surfaces. So we see here that the operation that it's going to do is going to create a new body. Now sometimes you are going to have these, you notice how this is, all the edges are green. There are going to be times where you have some red edges. That indicates that there's a small gap in there. So what I would recommend you to do is either play around with the tolerance a little bit. So increase the tolerance, and that should get rid of the error. So if you can't create a new body for the operation, and you see a red line, so, I would just recommend kind of playing around with the tolerance a little bit, seeing if that gets rid of it.
And if it doesn't, you're just going to have to go back into the model and find out where that free edge is and just close that gap up a little bit. And then you should be able to do it. I see this a lot happen when people are trying to bring certain files into Inventor, and they're coming in as like, it's like, oh my god, my file's coming into Inventor as a surface model, and I can't stitch it. Why? A lot of the reason is there are free edges in that model, and sometimes it relates to like things triangulating at an end, and sometimes those create some weird edges as well. So,
all right, so let's go ahead and click OK. And we see here that we indeed have a solid body now. So we jump into the model workspace, just to double check that it is. Let's go to section analysis. So this pretty much allows us to see a cross section of the part, and we see that it is solid now. So let's go ahead and just create those fillets. If we take a look at the canvas, we see that it's kind of rounded off at the top. So let's just go to modify, fillet. And let's do a 1.6. Click OK. Right click, repeat fillet. Just do a 1 millimeter is fine. Okay, and here's our finished solid body that we created from our sketch. So let's go ahead. Our final step now is to save it as an STL. So pretty much by doing that, it allows us to get it ready for our 3D printer. So to do that, let's go ahead. We can either right click on your body, solid body, and save it as an STL, or if you come up here to the top, click on Make 3D Print. We see the dialog box appear, which you're going to get the same result if you would have saved it as an STL. So we see that our body is selected. Fusion 360 gives you the option to view, the mesh. We zoom in here, we see that it's pretty much made up of a lot of small, tiny triangles. You can also mess around with the refinement. So now the more triangles that we have, the smoother finish you're going to get. But you also have to keep in mind that it's going to be a lot more time consuming in the long run.
Certainly, yeah, it'll take longer to print. It'll take longer to generate that STL as well.
But for today, let's go ahead and stick to Mesh Mixer. If this is your first time using Mesh Mixer, you are going to have to download it. So the program is completely free. So just feel free to give it a try. Let's go ahead and click OK. And we see here, we see here that we get a preview of what it's going to look like in your 3D printer. So Mesh Mixer comes pre-installed with a couple 3D printers. So if you look here, we have a Stratasys, we have MakerBot, we have a couple more over here. So if your 3D printer doesn't appear here on the options, just try to find something that has a similar build space to what you have. If you want to get a preview of what it's going to look like in your 3D printer. So let's go ahead and rotate it. So if we click on transform, you can move your part around. So this helps if you want to visualize how it's going to look with extra models in here, or if you can insert another part, or if it's going to fit. So this is an extremely handy tool to have, just to verify that all your parts are going to fit within your 3D printer. So let's just go ahead and click Move to Platform. You have all these other options right here. Move, if you want to rotate it, and then have some sort of support on the bottom, you can definitely do that. Let's see here. Now, if we 3D print this out of solid material, it is going to, it's going to get kind of pricey. So let's go ahead and hollow it out. So Mesh Mixer gives you the option to hollow out your part and give it some sort of a shell. You can just change the value here, 1.6 or wherever you like. Click on Done. It also gives you a little preview of what it's going to look like. So we zoom in. It kind of shows it here of what your model would look like. Click on Done. Okay, so if you had some overhangs, you would definitely want to add some supports to it. So Mesh Mixer gives you that option to create supports for any overhangs that your part might have. Being that we don't have any overhangs on this part, I'm just going to leave this alone. So click on Done. Now, if you have your 3D printer hooked up to your computer, you can just go ahead and click Send To, and send it directly to your 3D printer. If not, you can definitely save this file locally onto your computer. So just click on Export, and it gives you that option to save it locally. Save it to your USB or your floppy disk. You used to use those if you're still into that. And yeah, so here, guys, you saw what we did in the course of 20 minutes. So we brought in a sketch, a concept sketch, and we created the 3D model, the surface model of it. And we're here at the final step of creating a 3D printing fully functional prototype of your part. So it's extremely useful. Fusion 360 is an extremely useful tool to have. It just gives you that capability to, just like Nigel said in the beginning, go from the beginning to end of your project.
Certainly. So, it makes a lot of sense to use 3D printing for certain applications. Obviously not for everything. When you need a strength of material, or you're trying to test a part to hold like multiple tons, or that's kind of like detrimental to the success of your product in terms of strength. That's something you might not want to use PLA or one of those other plastics for. Certainly not a replacement for steel in some applications. But in regards to fitting and such, it's super awesome.
Yeah, great machine to have, especially for prototype, like you were saying. You just verify, it gives you that extra sense of assurance, that your part is going to fit or it's going to work the way it's supposed to.
Certainly.
Okay, so now guys, if you have any questions or comments, this is the time to ask.
Definitely, yeah. So go ahead and type those questions into the chat box at any time. We'll be more than happy to address them. There are a couple that are coming in. I just want to note too, like another use case here for 3D printing. Just real life example. So I had I got some aftermarket brake calipers from my car that weren't built for that particular model. I had a car that's relatively weird. So what I did is, right? So what I did at that point is like, well, I have to make brackets to go from this factory mounting point to a larger caliper. And I was planning to make them out of steel or aluminum or something. I was figuring
outsourcing to get a machine.
Exactly. And obviously I wanted to see if it would fit. I wanted to do a test fit. So my buddy, this was a couple of years ago, this is when I was still in college, my buddy had a 3D printer that he made.
Oh,
It's
really?
super crazy. Used some open source software to do it. We built a test part in SolidWorks, and we printed it on his 3D printer. We mounted it up to my car with a new brake caliper. Obviously, it wasn't going to hold the weight, so we supported it there. It was kind of just there to make sure that that configuration, was, yeah, exactly. Ended up working, and then I ended up not actually using those brake calipers, but it was like super cool. Where it's like, okay, so this is actually going to work. You can do some cool stuff in regards to the design. I did some really funny engravings into that bracket. So just another use case for that. So we'll go over a couple of these questions here. One, you might not believe that this is a question every week, but it totally is. Will we be recording this session? That is a very much yes. The session is always recorded, and unless there's some kind of like catastrophic failure in regards to our recording, it'll be up that afternoon or by the latest the next day. So expect to see this presentation here up on YouTube, our KETIV Technologies YouTube channel sometime this afternoon or tomorrow morning. Also note, in regards to tomorrow morning, we've got something really great. Alex is actually on another presentation tomorrow morning. If you haven't heard already, you might have received some emails about this, but here at KETIV, we're starting a second series of webcasts in addition to ABA that are happening on the first Friday of every month. And we're calling them Fusion Fridays.
We are.
Hey, that was kind of cool. We kind of got that together there. So I'm going to go ahead and leave a link in the chat box right now, so feel free to jump to that at any time and sign up if you haven't already. Tomorrow we're going to be doing kind of a general overview of Fusion 360, what it is, what different capabilities there are within the tool, because it is much different than a lot of other tools in the same, I guess, space. Whereas Fusion 360 can do all of your, like as you showed today, you can take it all the way to fabrication with 3D printing.
Correct.
You can also do the same thing with CAM, so you don't have to, jump into a program like Gibbs CAM or Mastercam after you generate your parts to, send it to your CNC.
Yeah. Also, those videos are going to be pretty much building upon each other, right? So we're gonna pretty much have tutorials for people that will need help with Fusion 360. So if you need help with Fusion 360 or are looking for a place to learn Fusion 360, we are going to start a little bit with some basic topics, sketching or surface modeling or just basic extrusions that you can do with Fusion 360. But we are going to start from the very beginning. So if you're new to Fusion 360, be sure to check those videos out.
Exactly. Hopefully that answers your question, Andy. In addition to what KETIV is doing for Fusion Fridays, there are a lot of great tutorials on YouTube. There's a lot of users on YouTube that just generate content, which is super amazing. It makes the learning experience so much easier and interactive when you can just watch a video for 20 minutes and learn how to use a completely new tool, or at least a new feature within the tool that you're already using. There's like it's always said, there's like 1,000 ways to build a single part.
There's really no.
Exactly. The way I would have built the part Alex built today might have been a little different than he did. And it's always interesting to see what other people, see as their design process, what steps they do first, and their process in regards to getting that same finished part could be way different than yours. And that's where YouTube really comes into play. You can watch people and their particular workflow. It's certainly amazing. Let's see, and this question came from Joseph. Does Autodesk have a slicer? It's a good question. I'm going to have to come back to you with that, Joseph. Expect an email from me later today. I need to look into that a little bit more. And then, let's see, this question's from Paul. Hey, Paul, it's nice to see you again. I've only used DMLS with aluminum, which has trouble with undercuts of 45 degrees or greater without support material. Is that true for other SLA methods? Generally, if you have any overhang, you definitely want some support material. If you don't know what we're talking about in regards to that, is say for example, we built a complex part where something is like hanging off the side. If you print that without support material, it's just going to extrude from the 3D printer and fall to the workspace underneath it. So you do need something like a support material. Generally, it is it's similar in physical properties. It's easier to but it's easier to break. So for those of you who don't understand what we're talking about, when we're talking about support material, it's most cases it's also plastic, and it's kind of built as like a frame. So you think of it as scaffolding for your 3D printed part. It's pretty much what it is. So there's that. Definitely, if anyone here on this call is already prototyping 3D printing parts for prototyping or even final use, there are some people who actually their finished parts are 3D printed parts. Let us know. We'd be really interested to find out what you're using 3D printing for, whether it be fitment, whether it be for just prototypes in general, or if your finished parts 3D printed, that's really cool too. Just definitely like to hear about all of the case stories that everyone has. Looks like I got a message here. And this answers Joseph's question. So Autodesk just recently added quote-unquote slicer technology to Fusion 360. It seems to exist, but I need to get some details for you, Joseph. So yes, it exists. Let me get some details for you in regards to that. On that same token, Fusion 360 is like ever evolving. For those of you who are using something like an Inventor or a SolidWorks or an AutoCAD, you do get like your massive update once a year where you like uninstall the software, reinstall the new version onto your computer. And this leads me to two things. There is going to be a next release of Inventor coming up here pretty soon. Can't tell you exactly when it's going to come out because I don't even know. So we're actually going to be having a presentation where Autodesk product manager Lauren Welch, I almost said Alan O'Leary, he's also a product manager. So Lauren Welch, I'm sure you've seen him on a couple of these AVAs before. He's going to show some of the new tech that they've included for the next releases of the software. So be tuned, or stay tuned for that. That's going to happen on about a month from now, on April 6th. So if you want to jot that down in your calendar for you Inventor users who want to see what's next in the next big release of Inventor, April 6th is that webcast at 10 a.m. So make sure you don't miss that. And the second aside from the releases is Fusion 360 was it Wednesday or Tuesday?
March 1st.
Yeah, so Tuesday, March 1st, they released a fairly large update for Fusion. You see Fusion updates every 6 weeks or so, sometimes even more commonly than that. And they've done a lot of improvements in the drawing area. Specifically, one of the big things that people were asking for is multiple sheets in one drawing. Yeah. And that's something that Fusion 360 didn't have until recently. So there is a link to that. Let me see if I can share it with you all real quick here, if I can find it quickly enough.
So what's neat about that too is that Autodesk has this specific forum, right, for people to come in and then actually tell them like, okay, how can you do this better, or how can you improve this? And they want to hear from you guys. So then they take all those considerations and they look at what people are, struggling the most with or need the most help with, and they actually include that or try to include that in their updates. So that's what's really neat about Fusion 360, and that's one of their main selling points too.
Certainly, and they're super transparent about what they're trying to release next. If you look at the Fusion timeline, I forgot what they call it, but there's a timeline for the next couple of months what they plan to release.
Sheet metal being one of the. They have a beta version of sheet metal, but they are gonna release it soon in the upcoming months.
Full-blown release, yeah. So if you saw there in the chat box, I sent the March 1st update for Fusion. I'm sure we'll share this in a blog post or something. But if you want to see what was in that update, they go over a couple of videos and some really important stuff within there as well. I'll give everybody about 30 more seconds to add any more questions if you do have some. Definitely looks like a lot of them were answered actually during the presentation. So thanks, Alex, for that.
Yeah.
Again, I'd like to remind you all tomorrow morning at 10 a.m. If you're not busy and you want to see more Fusion content, definitely join us for Fusion Fridays. Hopefully we get the same kind of following as we have for AVA. It would be really great to have another community for people to just come on board, learn a couple new things, share their experiences in the new tools. So it'd be really great to hear. So it looks like nothing else came in terms of questions, but I'd like to thank you all for being here again today.
Definitely. Thank you guys.
If it wasn't for you guys all being here listening, we wouldn't put these on. So so certainly thank you all for that, and we'll catch you on the flip side for next week. And next week we're going to jump into 3D Studio Max or 3ds Max, which is something that's included in a lot of product design suites and product design collection subscriptions. So if you're not already using it, learn how you can. So we'll see you all next week. Thanks, everybody.